In the last 9 lectures, we've been discussing unsupervised learning. We first discussed clustering models, followed by matrix factorization approaches, and finally sequential models. And in all 3 of these types of unsupervised learning frameworks, we were looking to uncover interesting patterns underlying the data without necessarily having a prediction task in mind. In this lecture, we're also going to discuss unsupervised learning, but a fundamentally different approach from what we've been discussing previously. Today we'll discuss something called association analysis. So at a high level, association analysis is going to be the problem of finding highly probable subsets of data. And this is something we'll make more concrete throughout this lecture. To set up the problem, we can imagine that many businesses have massive amounts of customer purchasing data. So for example, Amazon has your order history. A grocery store would know objects purchased in each transaction. If you give them your rewards card, for example, they'll know the purchases made by whoever's identity is on that card. Other retailers also have similar data on purchases at their own stores. So using these types of data, we might want to find subgroups of products that tend to co-occur in either purchasing or viewing behavior. So, for example, retailers might want to cross-promote products through different deals by knowing that these 2 products are very highly correlated in the way that they're purchased. So we might want to have deals on both products at the same time. Grocery stores might want to strategically place objects. So this is the classical example where a grocery store would want to strategically place objects next to other objects because it would encourage a consumer to purchase them both at the same time. Online retailers can use this information to recommend content. We've already discussed one approach for recommending movies. In that case, we had actual user feedback on their beliefs, their thoughts about the movie through a rating. In this case, we might want to recommend content based only on viewing behavior, so we don't get any feedback, but we know that users tend to view different objects together in the same viewing session. And it's also something that can be generalized more fully. So let's look at the basics of association analysis through something called market basket analysis. So this is the canonical way of thinking about finding associations among data. So for example, let's think of, imagine that we have 5 market baskets. What this literally means is that we're assuming that somebody has a basket at a market or a grocery store, and they have different objects in their basket at checkout time. And we're going to look at 5 of these baskets, meaning we're going to look at 5 different people at checkout time in this very simple example. So what this would say is that the first person, or the first basket that we have, contains bread and milk in it, so it contains those 2 objects and nothing else. The second contains bread, diapers, and beer and eggs. The third basket contains milk, diapers, beer, and cola, etc., etc., etc. So imagine now that we have a lot of this data. We have millions of these transactions, and they're across thousands of products. We now might want to use this type of data to analyze patterns of co-occurrence. So which products tend to co-occur together, which objects tend to appear in baskets, at what percentage or what rate, and also to use these sorts of patterns to define association rules, and it's just another word for conditional probability. So for example, and this is the classical example that apparently was found in one of the first uses of this technique, we might find that people who purchase diapers also purchase beer. So we want to learn an association rule, and this one's a kind of a joke, where given that they've got one object in their basket, we're going to predict that it's more likely to have a second object in their basket. So let's make this problem a little bit more mathematically abstract. So what we're trying to do is to perform association analysis and learn association rules. And so first, let's imagine that we have p different objects. For example, there could be P different items for sale in a grocery store, and each of those items has a unique index from 1 to capital P, saying which object it is that's for sale. So then we assume that we have a collection of subsets of these items. For example, xn for the nth subset would be a subset of indexes from 1 to p, where we can think of xn as giving the index of the things purchased by the nth customer. And we're going to let n range from 1 to capital N. So x subscript n is like the market basket for the nth customer that says, that gives the index of which items are being purchased by the nth customer. It doesn't give the number of items purchased. For example, if milk is being purchased, it's not going to distinguish between 1 or 2 bottles of milk. It's just going to give an index that's saying milk is being purchased. So now there are 2 objects of interest that we want to discover. The first is to perform an association analysis, and this is simply to try to find subsets of items that have a high probability of co-occurring together. So to this end, let's define K to be a subset of index values between 1 to P. So this is a subset of items. And then P of K is now going to be the fraction of market baskets that contain those items indexed by K. So if K is an index of a subset of indexes, then the probability of that subset K is simply found by counting how many of these baskets contain those items in it indexed by K. So we want to count the number of n such that K is a subset of xn. The nth market basket could contain more items. We're only interested in whether the items indexed in the set K are contained in the nth basket. So we count the total number of baskets where this subset appears in, and then we divide by the total number of objects or subsets to begin with. So we want to find these subsets where K, where this probability is large. For example, we might define K to be peanut butter, jelly, and bread, and then we'll go and count how many of these baskets at purchase time contain those 3 objects together, and then divide by the total number of baskets to get the fraction of customers that purchase those 3 objects together. That would be P of K. So our goal is to find these subsets where this is a large number. A second goal is to learn association rules. So this is the problem of finding objects that are highly correlated, where knowing that a certain subset of objects appears in a set xn makes it more likely that another object is going to appear in that set as well. So to this end, let's let A and B be 2 disjoint subsets of the integers 1 to P. Then A, right arrow B, can be thought of as meaning that purchasing A increases the likelihood of purchasing B as well. So we want to learn these rules. For example, if we define A to be the set peanut butter and jelly, and B to be the set bread, we want to learn that that purchasing these 2 items increases the probability of purchasing this item